Now here is the fifth group of properties. We have sin inverse of x plus cos inverse of x equal to pi by 2. Then tan inverse of x plus cot inverse of x is also equal to pi by 2. And lastly sec inverse of x plus cosec inverse of x is also pi by 2. Provided of course their respective conditions are met. So here also we see a very clear pattern or a structure. The addition of two related inverse trigonometric functions gives us pi by 2. So that's the way it is. Let us try to prove the first property, and the same will apply for the other two also. Now here we have to prove that sin inverse of x plus cos inverse of x is equal to pi by 2. So for that, let us first consider or assume sin inverse of x to be equal to y. Okay, some angle y. Now since y is equal to sin inverse of x, clearly y belongs to the principal value branch of sin inverse, that is minus pi by 2 to pi by 2. That's a very important point. Okay. Now moving ahead, we can say that x then must be equal to sin of y, right? And now we can write that sin y is same as cos of pi by 2 minus y, because we know that that is always true. That's an identity for any angle y. But now in order to bring cos on the left side, you see that we cannot just do it as it is by default, because we have to first ensure that whether pi by 2 minus y belongs to the principal value branch of cos inverse or not. If it does, only then we can take cos on the left hand side and then say that cos inverse of x is equal to pi by 2 minus y, right? So for that we have to first check where does pi by 2 minus y belong to. Okay? For that, let us look at our original assumption that y is the angle that lies in the principal value branch of minus pi by 2 to pi by 2. So from that y, let us derive where does pi by 2 minus y lie in. Okay? So we know that y lies between minus pi by 2 to pi by 2, correct? Since we got minus y, let us negate everything. So therefore we can say that pi by 2, since we are negating the inequalities, will reverse, greater than or equal to minus y, that in turn is greater than or equal to minus pi by 2. Then we want pi by 2, so we add throughout pi by 2, so therefore we get pi by 2 plus pi by 2 greater than or equal to pi by 2 minus y, which is greater than or equal to pi by 2 minus pi by 2. So clearly we have pi greater than or equal to pi by 2 minus y, which is greater than or equal to 0. So just rewriting that in the opposite order, we can say that 0 less than or equal to pi by 2 minus y less than or equal to pi. So here see what we have obtained. We have proven that the angle pi by 2 minus y belongs to the interval 0 to pi, which happens to be the principal value branch of cos inverse. Okay, so therefore now we can say that, yes, we can now say that cos inverse of x is equal to pi by 2 minus y. So therefore we can now substitute y with sin inverse of x, that is what we had assumed it, and bringing sin inverse of x on left side, we get sin inverse of x plus cos inverse of x is equal to pi by 2. So that proves the required property. Alright, similarly we can prove the remaining two properties also. Okay. Let us solve one simple sum based on this property. If sin inverse of 1 by 5 plus cos inverse of x is equal to 1, then find the value of x. Now here on high level, if you observe that sin of something is equal to 1, let's ask the question, so what must be the angle? right? It must be sine inverse of 1, and that is nothing but pi by 2 or 90 degrees that we know. So therefore we can say that sine inverse of 1 by 5 plus cos inverse of x must be equal to sine inverse of 1, that is equal to pi by 2. So we have sine inverse of 1 by 5 plus cos inverse of x is equal to pi by 2. But we have already seen the property that sine inverse of some value x plus cos inverse of the same value x, where x belong to -1 to 1, is always equal to pi by 2. This is a property that we just proved. So therefore if you compare that with whatever we have got, that implies that x has to be 1 by 5. That's the answer.